The hardest part about number 9 is setting it up. So as soon as you see a raised to a power, you know that the other way to express it is with a radical symbol. Whatever's down here in the denominator is written out here, side here on the radical symbol. So inside the symbol is 1 over 25, and what's written in the numerator is to the third power. That's how we set it up. Now to start solving it is to first break it up. So we're going to break it up as the square root of 1 over the square root of 25. And then once we solve that stuff, we're going to take it to the third power. So again, it's understood to be known a 2 here if it has been eliminated. Now, the square root of 1 is simply 1, and the square root of 25 is 5. But we still have to cube that. So I'll do that over here. So 1 cubed and 5 cubed, when we evaluate that, 1 cubed is 1, and 5 times 5 times 5 is 125. And that's our final answer. So the hardest part about this problem is setting it up and then solving it. All right, number 10 is the square root of 25x squared. Now, you can always break this up with the number and the variable because this means the same thing. They're both being multiplied. Now, we know the square root of 25 is simply 5. So we can write that one out. So that equals 5. And then we didn't do anything with x squared yet. But the other way to represent this radical symbol is to convert it to a fractional exponent. So I'm going to rewrite it as 5, and then this part as x raised to 2 over 2. Because remember, there's a 2 over here. It's just been eliminated. So we know that 2 over 2 equals 1. So this becomes 5x to the first power, or you can simply just write it as 5x. Now, number 11. There's two ways you can solve this. You could either write it as 1/2 times the square root of 50 divided by 2. Make sure I don't forget my x. You could either write it like that, or you could simply write it as, 25 times the square root of 2x. And when you evaluate this, we know this will reduce down to 5. This is 5. And we could also reduce this down one step further. So let me write it out for you. So if we have 5 square root of 2 square root of x over 2 square root of 2, you can see now that these two will reduce down to 1. So my final answer here is 5 square root of x over 2. Now that's if we used this method here. Okay, and that's the answer for that. So I'll show you how this looks if we use this method. So let's start with that. Well, we know that 50 divided by 2 is simply 25. So I'm going to rewrite this as 1/2 times the square root of 25x. Now, when we evaluate that, that becomes 1/2 times, and then we have 5 comes out, but the x remains in there, 5 square root of x. So our final answer here, we can't take the x out of the square root. There's no way to solve that any further. So our final answer is 5 times the square root of x over 2. Either method would work. All right, for number 12, we have the square root of -18. So recall that when it comes to imaginary numbers, if you have the square root of -1, that is your I. Or if we have I squared, that will be -1. So as soon as you see this type of problem, you should perform the very first step, which is pulling out that -1. So we have -1 times the square root of 18. Sorry about that. So we know that this will simply be replaced with an I. Now we got to work on solving the square root of 18. So I start thinking to myself, well, we know this is the square root. This is 2. So I start thinking of perfect squares. Well, I know 2 squared is 4, 3 squared is 9, and 4 squared is 16. So I start thinking of those two factors. Well, I know 9 times 2 equals 18. So I can use those two factors. And if so, that becomes the square root of 9 times the square root of 2. And we know that this will evaluate to 3. And we can't take the square root of 2 and get a whole number. So our final answer for this one would be 3 times the square root of 2. And and I forgot my I. Sorry about that. I can't forget to make sure to include the I in the final answer. So number 13 is this negative square root of 15 times the negative square root of 15. So again, the first thing I'm going to do is pull out that negative 1 and just write it out. Now I can gather we have 2 of these times 2 of these. Now remember, whenever you have the number here and the number as the power are the same, this simply just comes out. And why is that? Because really it's 15 to 2 over 2, which equals 15 to the first, which is simply 15. Same with the negative 1. So we can evaluate this as negative 1 times 15, and our answer simply is negative 15. Now, the only way we can divide this with these imaginary numbers is we have to multiply it by we have to divide by the conjugate. And what do I mean by that? So whatever is sitting here, we're going to multiply here and here. But, however, this sign must change. All right, so let me show you what I mean. 2 minus I over 2 plus 5I. Now we're going to multiply the top and the bottom by 2 minus 5I over 2 minus 5I. So you can see that we took everything here except for that piece. It's the only thing we changed. All right, so let's go ahead and work that out. So we're going to multiply first, and then we're going to combine like terms. So we're going to work with this 2 first. So 2 times 2 is simply 4. 2 times now minus 5I is a negative 20I. Now we have a negative, think of it 1I times a 2. So that would give us a negative 2I. And then we have a negative times a negative. And this here, let me erase that so it's not confusing. Okay, now this one is a negative times a negative, which would give us a positive answer, which is 5. And then if you look, there's 1, 2 i's, so it's I squared. Let me put a line over that. Now we're going to go to this. So we have 2 times 2, which is 4. We have a 2 times minus 5i, which would give us a negative 10i. Here we have the same thing, but it's 5i times 2. Now we got a plus 10i. And now we have a 5i and a minus 5i. So that's opposite signs. So we end up with a negative. 5 times 5 is 25. And we have 1, 2 i's. So that's I squared. Now, if you notice at the bottom here, this and this zero out. So that goes away. So this now we have to replace this here, the I square. Remember, that becomes a negative 1. This becomes a negative 1. So on the top, it's plus 5i. Plus 5 times a negative 1. And on the bottom, we have a negative 25 times a negative 1. So this becomes a negative 5. We multiply this out, it becomes a plus 25. So now I'm going to rewrite that. So on the top, I have 4 minus 20i minus 2i, and now we have it as a minus 5, this part here. Now on the bottom we have 4, and now we have to replace this stuff here. We now have, which is here, we have a plus 25. So in reality, if you look right here, all it does is it gets rid of the I squared here, and you can see it just changes the operator, minus 5. Same with this. Over here, it just, instead of becoming minus 25, it's now a plus 25. All right, so now we're going to finish combining like terms on the top. So on the top piece, we have a 4 and a negative 5. And then also we have these two have i's, so we can combine those two. We have 4 minus 5, and then we have a negative 20i minus 2i, all over, and we know 25 plus 4 is 29. So our final answer here would be a negative 1, and then we have, remember, a negative 20 minus 2 becomes simply a negative 22i over 29. All right, for number 15, all we have to do is factor, and we're going to set up our parentheses. With this x, since it's squared, all we have to do is write the x each time. Now, this operator here, plus, is telling us that whatever this is, it's going to be the same. Okay, that means it's going to be x plus, x plus. All right, now, what do we do to get this number and this number? All right, so I'm going to look at 16. 16, the factors there could be 16 times 1, or you can use 8 times 2, or 4 times 4. So the goal is that whatever I place here, it will end up giving me this value here. All right, so I am going to go ahead and choose 8 and 2. Okay, 8 and 2. Now, if I was to multiply this back out, I want to make sure that I come back this right here. So I have x squared. X times x gives me x squared, and x times negative 2 gives me negative 2x, negative 8, and x. And then a negative gives me positive 16. And if I was to combine these like terms, and then that would be plus negative 8, that would give me a negative 10x. So this is correct.